Okay, so today we'll be going through kinetic model of matter. So this is not a very difficult chapter. Actually, you have gone through this before in chemistry, so it shouldn't be very difficult. But basically in this chapter, we're looking at how do molecules move, and you're looking at it through solid, liquid, and gas. So let's start off. Okay, so I'll toggle between here and the notes so that it's easier for you to follow. Okay, um so what is this whole entire chapter about, right? So the simple model of matter tells us that tiny particles that make up matter are in continuous continuous motion. Okay, so it's just basically telling us that all the particles that make our solids, liquids, and gas are moving in a continuous motion. They are always moving. Okay, and then according to the kinetic theory, molecules, atoms, and ions are held together by intermolecular forces or intermolecular bonds or intermolecular forces of attraction. We're not too particular about this in physics. Okay, so this is what, yeah, so as you can see for solids over here, right, for solids, what is happening, we know that solids are closely packed, right? So they move very slowly and they vibrate in one place, whereas in the case of gases, they are very far apart. The distances are very far apart from one another, and therefore they will move at very fast speeds in random directions and all. But we'll cover that later. Okay, so let's just go through. So solids, right? As example, this is a log over here, right? If something is a solid, they have a definite shape and a definite volume. So what does this mean? It means that they have a specific shape and size unless an external force is being acted on it. Same thing with the volume. Let's say I have a 100 ml glass of water, right? Or you have your water bottle that holds maybe 800 ml of water. That water bottle is forever going to hold 800 ml of water unless it's being crushed or something. Okay, and if it has a fixed mass and also a fixed volume, it implies that it will have a fixed density, because we know that density is mass over volume. Okay, so this is just a recap of what we have learned so far in physics and also in chem. So now let's get down to the important stuff, which is how are the molecules arranged. For solids, right, they are closely packed, and as you can see in chemistry, it goes more in depth, right? It goes more in depth and it says that solids are closely packed in a fixed lattice structure. Okay, but this is for chemistry. For physics, we just need to know that it is closely packed in a regular pattern and a fixed shape. Okay, so the first important thing you need to take note is this. Okay, closely packed. Okay, this is the first important thing if you haven't already memorized. The second most important thing is a type of attractions. So how do we know the type of attractions, right? So for solids, they will vibrate about fixed positions. Okay, why? Because they have a very strong intermolecular forces of attraction. So this is very important. You need to tell me vibrate about fixed position. Okay, this is a very key word that I need to see your answer. So the two keywords, if you forget everything else, remember, first of all, they are closely packed. Okay, here, closely packed. And second, right, if you talk about the way they are moving, right, it is talking about how they vibrate about their fixed position. So two keywords here, closely packed and vibrate about fixed position. If you need to highlight this on your notes, please highlight it. Okay, now we move on to liquids. Okay, so for liquids, yeah, I would say this is like the in between gas and solids. Okay, so that's how you remember. Okay, so remember down here it's strong attraction, right? So for liquids, what would it be? Okay, liquids, we know it has an indefinite shape. What does indefinite shape means? It means it takes the shape of the container or whatever is being placed into. If I pour water into a square shaped cup, it will be square. if I pour it into a circle cup, right, versus a square, right, it will produce a cylinder, shape of a cylinder. Okay, definite volume means if I pour 800 ml of water, right, 800 ml will be produced. Okay, you won't lose the water out of nowhere. Okay, it's not that fast. Okay, so let's move on to the important stuff, which is, first of all, okay, how is it being arranged? It is arranged in a random manner. Okay, as you can see over here, random manner. Okay, so if it's randomly arranged, right, okay, it's not as closely packed, right? So the particles are further away from one another. As you can see down here, this is liquids, right? And if we scroll back up, this is solids. Solids, they are all together. They are in a fixed regular arrangement. But as you can see for liquids, what's going on? Liquids, they're still close together, right? But they are separated. Some parts there's a big gap over here. Some parts there is a small gap over here. So that's the case for liquid. They are randomly arranged, okay? So if they ask you, okay, what is the attraction? Remember just now in solids we learned that is closely packed, right? So for liquids, can write it is less closely packed than solids, or you can write moderately packed. So as you can see, right, they are closely packed, right, but they are not as closely packed as solids, right? So you can write less closely packed. So I write this for you. You can either write, okay, you can write less closely packed than solids, or I can write moderately packed. Okay, so these are the two options when it comes to arrangement. Okay, this is for arrangement. Okay, I'll simplify over here for you. Okay, and then we go to attraction. Attraction, same thing, right? You know, it is more, has a greater attraction than the gas, right? Because the gas is further away, but it is less attractive than compared to solid. So I can also write moderately attractive forces. Moderate attractive forces. Okay, or just tell me it is less strong than solids but more strong than gas. Okay, so and then the kinetic energy, right? So they have high Ke, so they will, what's the important word here? It will slide past each other. Okay, they will slide past each other. Okay, so the things that I need you to remember are, it is moderately packed or less closely packed than solid. It is, they slide past each other. So these are the two key things that you need to help me remember. Okay, so with that we move to gases. Okay, so gases, right? Gases, they have a indefinite shape, right? Same thing with water. Let's say same thing with the water example of a bottle, right? If I have an empty bottle of water and it's a square shape, and I remove all the water, there will be air inside, right? And air will take the shape of the container. Okay, indefinite volume means that let's say I have a hot air balloon versus I have a water bottle, right? The air has no fixed volume, okay? Because the particles can move everywhere, right? You know the gas molecules, they're so far away. So as you can see over here, right? So the gas molecules are very far apart, right? They're so far apart. Look at the distance, right? Just now, at least there are some, but look at all the distance. And is it regular? No, as you can see, right? Some of the distance is further away from one another. So it's not the same distance. So they are widely spaced. Okay, they're very far apart. You just use very far apart. Okay, they're very far apart. They have high energy, right? Because they are moving at great speeds. Okay, high energy just means they are moving at great speeds, and this fills the space that they occupy, means they have no fixed volume, and they have, okay, this is why it's important also, negligible forces of attraction. Okay, so if I add negligible forces of attraction, I do believe everything is filled up in your notes already. So whatever is in your notes, just remember those, okay? Remember those. It's like over here, right? The table over here, okay? High speeds over here, far apart, randomly arranged, free to move, they will slide past one another, closely packed, vibrate about fixed position. Please highlight these and memorize them, okay? These are very, very important when it comes to answering questions, okay? These are free marks. Everybody's going to get it, so don't lose out on these marks. Okay, so as a summary, right, over here, right, we have solids that are less closely packed, very closely packed. They have a strong intermolecular force of attraction. They vibrate about the fixed position. As you can see down here, these are the three things that they can test you, which means these are the three things you need to give them in your answers. Okay, and then we talk about liquids, right? Liquids are randomly arranged but are slightly away from one another. They have some attraction, okay? If I want to be more specific, I can change this to moderate forces of attraction, okay? And they are free to move about and they will slide past one another. For gases, okay? So this whole entire chapter, right, the main thing you are focusing on for kinetic model of matter will be the gases, okay? Nonetheless, these you also need to know, you also need to memorize. But for the most part, gases is what they're going to test you with, and that's what we'll focus on. So for the motion, right, gases, they are in continuous random motion, okay? I'll refer to this as CRM throughout this whole entire video, continuous random motion. Why is this so important? Because this is what you have to give in every single answer. Imagine they ask you, okay, how is the gases move? Then you must tell me they move in a continuous random motion, okay? Continuous random motion, okay? So I hope I repeat this a lot of times, you get this into your system, okay? Continuous random motion, okay? So first thing, see this blank over here. What is Brownian motion? Okay, Brownian motion is continuous random motion of the particles. Okay, and this is often in liquid and gas, not your solids, only liquid and gas. So if you go back here, okay, so what's the history of Brownian motion? Okay, so just to give you I won't spend too long on this. It was just basically a botanist, right? So this guy that studies flowers, he was looking at pollen grains under a microscope. Okay, and then this is how he observed the pollen grains to look like over here. These are the movements, okay? This over here, right? This is how the pollen grains move after a specific time. So he plotted how do they move. Okay, as you can see, okay, so they move in a continuous random motion. Okay, so here, okay, sometimes they'll ask you a question. Some possible questions they can ask you is, draw the motion of I don't know, Brownian motion. Okay, draw Brownian motion. Okay, so all I need to do, you need to show me that there is a zigzag pattern. Zigzag manner. That means you can draw something like this. Okay, arrow, draw something like this. Okay, and then shade this arrow here so it's clear for them. Yeah, something like this. Okay, yeah. Okay, so motion, just make sure it is in a zigzag pattern. Okay, so what is the experiment? Okay, the experiment is basically, okay, what do we do? Okay, so we put air cells over here containing smoke particles under a microscope. Over here. Okay, so air cells are placed into this glass cell over here, okay, over here, this glass cell over here, okay, and then I shine a light source. It can be a lamp, it can be an air cell and everything, and then I observe the motions through the microscope. Why do I need to use a microscope? Because all these movements you cannot see them through the human eye. I need to enlarge it so that I can see. Okay, so can you help me to draw this diagram? Okay, I'll pause the video here for a short while. Can you draw this diagram? Okay, and then can you also label all the parts for this diagram? So over here I have a light source, I have a glass rod. Okay, the glass rod is just the glass rod is just to show you that the light rays will converge at one point. That means they will come together. Okay, all this what you're drawing over here are these arrows over here are the light rays from the light source. Okay, and then it will go through this glass cell over here. Alright, and this glass cell is where I can observe the particle movement. So this glass cell over here, right? Over here, this glass cell over here will contain the smoke particles. Okay? So I'll give you maybe 1 more minute to draw this. Okay, we'll continue at 3:38. Okay, so I think you drawn finished it. Okay, now I'm gonna wait until 3:38. Okay, so let's go through this. Okay, so what are the observations? Okay, what are the observations? The observations that you notice is that, okay, the particles are moving in continuous random motion, right? We are familiar with this, and they are unevenly being bombarded from all directions and sides. Okay, so let's fill in the blanks. So they are moving in a continuous random motion, and this is because they are being unevenly bombarded in all directions and sides. What does unevenly bombarded mean? The word bombarded means they are being essentially hit from all by the air molecules. Okay, so what are these bright spots of light? Okay, these bright spots of light remember these are the smoke particles. Okay, this is not the air molecules these are the smoke particles. Okay, as we can note you are observing the pattern of the smoke particles. Okay, you are observing the pattern of the smoke particles. The air molecules are banging against the smoke particles to cause it to move in such a manner. Okay, so sometimes they can ask you, okay, what is the purpose of the microscope? Okay, the purpose of the microscope, right? We know that all these cannot be observed under the naked human eye. So the purpose of the microscope is to enlarge the smoke particles so that its movement can be studied. Okay, so this whole entire experiment down here shows me that the molecules are moving in continuous random motion. Okay, now let's move to the next part. Okay, the next part tells me what is the effect of the temperature on the molecular movement. What would the temperature cause? Okay, you know, when I heat up the gas, right, what happens? The gas gets more excited, they get more energy, then they will speed up everything. So how do we phrase it into the proper way so that we can get all the marks in the exam? Okay, so this part is also very important. Okay, so just memorize this part also. Okay, this whole entire chapter is really just memorize. Don't need any formulas, no need any mathematical stuff, just memorize. Okay, so this part over here, the air molecules bombard. Okay, remember bombard is the meaning hit. Okay, you need to get this into your system. Bombard. Okay, the air molecules are bombarding the smoke particles. The air molecules are hitting the smoke particles. Use bombard exam. Okay, more quickly and they are bombarding the smoke particle more quickly and with and harder and harder and harder. Okay, so when the temperature is raised, right, the air molecules they hit the smoke particles faster and harder. Okay, this means that the air molecules have greater speed and at higher temperature. Okay, remember that when I increase the temperature, what happens? That means kinetic energy increases, right? Because kinetic energy is linked to the temperature, and therefore kinetic energy, remember we learned it is half mv squared. So that will be increase in speed also. Okay, so when the temperature increases, right, what will happen? A larger amount of thermal energy is converted to kinetic energy, right? Kinetic energy. So it will cause the molecules to move faster. Okay, it causes it to move faster. Okay, so this part should be fine. Okay, so just memorize this part. Okay, so everything in this chapter just memorize. Okay, so now we move to the next part. What is total internal energy? Total internal energy is kinetic energy and potential energy. So in the case where they ask me what is internal energy, okay, just tell me it is the sum of kinetic energy and potential energy. It means kinetic energy plus potential energy, okay, equals to internal energy. Okay, and kinetic energy is affected by the speed of the molecules. Potential energy is affected by the forces holding the molecules together and how far they are away from each other. Okay, so let me jump back here for a quick period. Okay, so what is the effect of molecular motion? Okay, this guy is gonna get more excited, right? So he will have a higher temperature, they will have a higher Ke, so they will move faster, they will bombard the walls, right? Bombard the walls means to just hit the walls, they will exert a greater force per unit area because we know that pressure equals to force over area, right? And therefore it will lead to a greater pressure. Okay, so we'll go through more that later. Okay, so the gas molecules, right, are moving in a continuous random motion. Okay, and so this thing is the very key thing about this whole entire chapter. Everything is in continuous random motion. If it's a gas, if it's a liquid, they're always in continuous random motion. And each molecule collides with the walls, exerting a force on the walls. Okay, be more specific, you exert a force per unit area. Okay, force per unit area is just basically force over area. That's what it means, and we know that force over area is pressure. Okay, this shouldn't be unfamiliar to you. Okay, so what will happen? It will affect the average force per unit area. Why do I say average and not just force per unit area? Why is it important to include the word average? The word average tells me that it is everything, all the molecules sum up, divide by the number of particles. Okay, sorry. Then the total amount of force divide by the number of particles. Because some particles might be banging it at a greater force, some particles might be banging it at a slightly greater force. Right, so we need to calculate the average. Okay, so the pressure exerted by the gas is the force per unit area exerted by the gas on the surface. Okay, so the key word here is average. So this part is also very important because sometimes they ask you, how does the gas exert a pressure on the surface? Okay, and then you need to tell me this whole entire chunk here. The gas molecules are moving in continuous random motion. They will exert a force per unit area, and then this will cause the average force per unit area to result in a pressure being exerted on the walls. Then just yada yada yada. Okay, so I'm not gonna go through this. Okay, so what does pressure depend on? Okay, pressure depends on one, your force per unit area. Two, it depends on the frequency of collision with the wall. Okay, so if I write down here in a different color, force per unit area, so the greater the pressure, it just means it is the harder it bangs the wall. Now the frequency of collision with the wall means it means how many times does it hit the wall. Okay, so if I want to be more specific, harder means the amount of force it hits. Okay, frequency means how many times does it hit the wall. Okay, so recap here. So internal energy is the sum of kinetic energy and potential energy, and temperature measures kinetic energy. Okay, so I want to emphasize one thing here. When is there an increase in potential energy? Over here, okay, when there is a thermal expansion, you know that certain, when I crushed something, that is contracting. If I heat up something, what will happen to the gas? The gas will become hotter. Yes, that's getting kinetic energy. But what else is happening? It is expanding. Remember, when you blow a balloon, right, it's getting bigger and bigger. That's the meaning of expanding. Thermal expansion means it gets bigger due to heat. Okay, so that's when potential energy increases. Okay, potential energy does not affect by temperature. When I increase the potential energy, okay, the temperature does not increase. This is only kinetic energy can increase the temperature. Okay, and then we recap the two factors are force per unit area and frequency of collision with the wall. Okay. Okay, so what is pressure and temperature? What is the relation? Okay, this is just the final part. The pressure of a fixed mass of gas is what? If pressure increases, what will happen to the temperature? Okay, I'm not sure if you will learn this formula later, but we learn this PV equals nRT. Okay, I think you have learned this in chemistry. So if pressure increases, what will happen to temperature? Temperature will also increase. Okay, so it is proportionate. Proportionate. Okay, it just means when I increase pressure, what happens to the temperature? Temperature increases. Okay, so we need to explain in molecular terms. Okay, molecular terms. So first thing you need to think of is the molecules are in continuous random motion. Okay, and then after that I need to say when the temperature increases, what happens? The molecules will gain energy and start to move faster. This will result in the molecules what? Colliding with the walls. With a greater force, right? It will exert a greater force, right? And frequency of collision with the wall also increases, right? Frequency of collision with walls increases. Okay, remember, it means the molecules are hitting the wall greater, but you cannot use the word hitting in the exam. You must use collide or bombard, and you must say it exerts a greater force and also bangs the wall more times. Okay, which means the frequency of collision over here. Okay, so since the volume is constant, the average force per unit area exerted on the wall increases. Okay, and what else? The pressure will also increase. Okay, as you can see over here, this graph over here, what does this graph show? This graph shows when temperature increases, what happens? Pressure also increase. Okay, So this table over here is basically a summary of whatever we have gone through. If you need to use answering techniques, right, to answer everything, to answer questions, right, this whole entire table here is very, very important. Okay, this whole entire table here, very important. Okay, so my suggestion is memorize this. Okay, this highlighted box in yellow, right? Please do me a favor and please memorize this. Okay, it will help you a lot in your exams. Okay. Yeah, so if you go left, right? Left is over here. Means if there's any change in temperature, what will happen? If you go right, what does this mean? It means any change in volume. Okay, then this is how you answer everything. Okay, so with that, okay, can you try the MCQs? Okay.